So, planets with two suns, like Tatooine from Star Wars, used to sound like pure fantasy. For decades, scientists believed these systems were too unstable to exist. Two stars tugging at a planet should fling it into space or drop it into one of the suns. Except, it turns out that nature didn't get the memo. Astronomers have found a planet calmly orbiting two stars like it's no big deal. This planet lives closer to its two parent stars than any other directly imaged planet in a binary star system astronomers have ever seen. Now, direct imaging means they saw the planet's light, not just its shadow. The whole system sits about 446 light-years away, so the light we see from it today left before humans ever built modern cities. This space monster is roughly 6 times the mass of Jupiter. And even more surprising, the planet is only about 13 million years old. That sounds ancient until you zoom out a little. Earth is about 4.6 billion years old, which makes this planet basically a newborn in cosmic terms. The two suns of this monster orbit each other incredibly fast and complete a full loop in just 18 Earth days. That means their gravity constantly shifts, yanking space around them like a cosmic washing machine. Even so, the planet stays locked in its path, so it takes it 300 Earth years to finish a single orbit. So nobody fully understands how this planet formed in the first place. When two stars orbit each other this closely, their gravity usually tears apart planet-forming material before anything big can take shape. Scientists have only found a few dozen planets like this so far, and that's nowhere near enough to piece together the full story. To solve the mystery, they need more data. Now, another cool find that still needs more research is a planet so stretched by gravity that it looks like a lemon, not a sphere. This planet is nothing like the calm blue and green worlds we see in space movies. It orbits a pulsar, which is basically a star's corpse. When a massive star expires, it collapses into an ultra-dense object that spins insanely fast and blasts radiation like a cosmic lighthouse. Being near one of those means game over for anything solid. And yet, this planet hangs on, barely. The gravity stretches it, pulling harder on the side facing the pulsar than the far side, like cosmic taffy. And here's where it gets extra unsettling. When scientists analyzed this planet's atmosphere, they didn't find water or oxygen. They found helium and pure carbon. No clouds, no oceans, no chance of life. According to everything we know about planet formation, this world shouldn't exist at all. So it might not be a planet in the normal sense. It could be the exposed core of a star that got shredded, leaving behind something stuck between planet and stellar corpse. That's a pretty scary trend. The line between planets and stars keeps getting blurry. And speaking of scary, meet this guy. This system lives around two red dwarf stars. These two stars orbit each other at a distance similar to how far Jupiter sits from the Sun. Scientists found two Earth-sized planets and a third possible one squeezed right up next to the stars. One planet completes a full year in just over 2 days. Another takes about 3.5 days. The candidate planet orbits even faster. To put that in perspective, these planets sit less than 2 million miles from their star. The Moon sits about 250,000 miles from Earth. So yeah, these worlds are close. When they combined data from space and ground-based telescopes, astronomers realized they were staring at something totally new – planets that transit or pass in front of both stars. Most planets in double-star systems orbit only one star, and this setup shouldn't last long according to the rules of physics. But these planets exist anyway, calmly breaking the rules. So this guy proves that planet formation works in ways we still don't fully understand, and space clearly enjoys messing with our expectations. Now, let's crank up the horror a notch. Astronomers made the first ever 3D map of a planet outside our solar system. And not just any planet. This one is so hot it literally tears water molecules apart. As the planet moved behind its star, the James Webb watched tiny changes in the star's light at different colors or wavelengths. Some colors get absorbed by water vapor, others don't. By stacking all that info together, scientists figured out temperatures at different heights and locations in the planet's atmosphere. And that's how they learned that parts of its atmosphere heat up to nearly 5,000 degrees Fahrenheit, hotter than molten lava. This superhot planet sits about 400 light-years away and weighs around 10 times as much as Jupiter. It races around its star in just 23 hours. 1 year there is basically a day. And because it's so close, the temperatures get so high. Winds try to move heat around, but they totally fail. WASP 18b's atmosphere barely has any water and instead overflows with carbon monoxide. Astronomers once believed water should be common in giant planet atmospheres. This world proves water is optional, not guaranteed. Now, magma worlds are another perfect proof of that. There's a huge group of planets called sub-Neptunes, planets bigger than Earth but smaller than Neptune. For a while, some scientists hoped these worlds were Haitian planets, covered in deep oceans of water or ice, wrapped in thick atmospheres. One famous example was K2-18. Its atmosphere showed methane and carbon dioxide, but almost no ammonia. But as it turned out, lava dissolves ammonia too, so the missing ammonia doesn't prove water at all. It could just mean the planet has a global ocean of magma instead. The researchers model how these planets heat up, cool down, and evolve over time. They asked a simple question: do these planets ever cool enough to stop being lava worlds? And the answer was almost never. When they tested thousands of known sub-Neptunes, they say almost all of them are likely lava worlds, not water worlds. In simple terms, these planets don't breathe water vapor, they breathe rock vapor. Their atmospheres come from magma boiling, not oceans evaporating. And that changes everything. Many worlds we once labeled maybe habitable turn into hellscapes the moment you run the numbers honestly. And that means space isn't hiding Earth clones, but mass-producing furnaces and other sorts of monsters. Take this bad boy, for instance. It sits only about 64 light-years away, which is uncomfortably close in cosmic terms, and it's the nearest hot Jupiter to Earth. From afar, it looks stunning, a smooth, deep blue marble floating peacefully in space. But that color hides something absolutely brutal. On this planet, it rains glass, sideways. Winds scream across the atmosphere at around 5,400 miles per hour, fast enough to shred anything instantly. The blue color comes from tiny particles of silicate, the stuff glass is made of, floating in the air. The planet's surface temperature hits about 2,400 degrees Fahrenheit, hot enough to melt rock. That heat turns those silicates into microscopic shards of glass that whip around the planet like a worldwide sandblaster. Standing there wouldn't hurt. You wouldn't exist long enough to ever feel it. And then there's the darkest planet ever found. It reflects less than 1% of the light that hits it. It's darker than coal, darker than black paint. Light just disappears into it. Not all planets even bother with stars at all. Astronomers have found rogue planets, worlds kicked out of their solar systems. These lonely planets drift through space in total darkness, frozen and untethered, with no sunrise ever again. Now, all of this shows us that our universe isn't designed for life. Life survives despite the universe, not because of it. Earth isn't typical, it's lucky. We're only at the beginning of this discovery era. Every year, new telescopes sharpen the picture, and every year, the picture gets stranger. The more clearly we see the universe, the less it resembles our imagination. And that's the most unsettling truth of all. Very recently, astronomers have found 3 potential super-Earth planets orbiting a somewhat close orange dwarf star. The term super-Earth is used to describe a planet beyond the solar system with a mass higher than that of Earth but below those of the ice giants of the solar system, Uranus and Neptune. An international team of researchers, led by Dr. Shweta Dalal from the University of Exeter, found that the exoplanets were orbiting star HD 48498, which is located around 55 light-years away from Earth. The planets travel around their star in 7, 38, and 151 Earth days, respectively. The study describing these findings appeared in the journal MinRes on the 24th of June, 2024. The coolest thing here is that the outermost exoplanet candidate orbits in the habitable zone of its host star. and the conditions there might be comfortable enough for liquid water to exist on the surface without boiling or freezing. Such habitable regions around stars are also known as the Goldilocks zone and are believed to be ideal for potentially supporting life. Another reason this discovery is so important is that the orange host star is like our Sun. But since it's an orange dwarf, it produces less radiation than our yellow dwarf star. It's also the closest planetary system to host a super-Earth in the habitable zone of a Sun-like star, which makes this discovery super exciting. It can help us move forward in our quest to locate habitable planets around solar-type stars. Who knows? Maybe this planet will be our new home one day. These potential super-Earths were detected thanks to the HARPS and Rocky Planet Search Program. Throughout a decade, the team taking part in this research has collected nearly 190 high-precision measurements using special equipment. By analyzing the spectrum of light coming from a star, astronomers can figure out whether it's moving toward us, this is known as blue shift, or away from us, that's what we call red shift. And still, to make sure their findings were correct, the team used lots of different methods and comparative analysis. Everything confirmed their conclusions. There indeed are 3 planetary candidates with minimum masses ranging from 5 to 11 times the mass of our home planet. The team also believes that the proximity of the star, together with the outermost planet's favorable orbit, can make this system a great target for future studies. Hopefully, further research will open doors for our understanding of planetary systems and the potential of life outside our solar system. Scientists have already discovered more than 5,000 exoplanets, which are planets outside the solar system, since the first such world was confirmed orbiting a Sun-like star in 1995. To find those distant planets, astronomers use different equipment, like NASA's Kepler Space Telescope, launched in 2009. Its mission was to find as many Earth-like planets dwelling in the Milky Way galaxy as possible. But it's not the only instrument used for searching exoplanets. Anyway, now let's look at the most exciting and promising of these worlds. Gliese 667 cc is a mere 22 light-years from Earth. But even though it seems close, it's still around 129 trillion miles away from us. The planet itself is around 3.8 times as massive as Earth and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares coming from its parent star, which is not cool on many different levels. Kepler 22b is way further away than the previous world, more than 600 light-years away from our planet. It was the very first Kepler planet found in the habitable zone of its star. This world is larger than Earth, it's about 2.4 times our planet size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler 22b is similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kind of like our Sun. But this star is smaller and colder than ours. Another Kepler planet, this time it's Kepler 69c. It lies a whopping 2,700 light-years away from us. This world is also almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 240 days to complete one orbit. This makes its position in its system like that of Venus in our solar system. At the same time, this world might be more habitable than Venus since its host star is a bit less luminous, 80% of our Sun. TOI 733b is a recently discovered world. It was found in 2023. It's out there, 245 light-years away from Earth, and needs just 4.9 Earth days to complete an orbit around its star. But the coolest thing about this planet is that it might have a massive ocean. According to scientists, the planet is likely to be completely covered with water. Does that mean there could be life on this super-Earth? Time will tell. GJ 1214b is located 48 light-years from Earth. This planet is a super-Earth, almost 3 times bigger in diameter and 8 times heavier than our home. It orbits around its red dwarf star faster than you can binge-watch your favorite series, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on JG 1214b create some cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo about being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated. The super-Earth that's closest to us was discovered in 2016, and it's called Proxima Centauri b. It's located a mere 4 light-years away from Earth and has a mass remarkably similar to that of our planet. A year on Proxima Centauri b is short. It only takes the planet 11.2 days to complete a circle around its central star. Scientists discovered this world after they noticed that its parent star was slightly wobbling. They hadn't been sure what exactly had been happening there until they realized Proxima Centauri b's gravity probably produced pulls and tugs that caused these wobbles. Although the exoplanet is traveling in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation, all because it lies very close to its parent star. Also, none of the telescopes that are currently working and exploring exoplanets are positioned well enough to capture the light from the atmosphere of this super-Earth. Most things there are still a mystery to us, even though we're talking about a planet that's really close. Super-Earth TOI 715b orbits a red dwarf, a star smaller and cooler than our Sun. At the moment, such stars remain prime candidates for finding habitable planets orbiting them. Those miniature rocky worlds have far closer orbits than those circling around stars like our Sun. But since red dwarfs are small and cool, the planets don't risk anything when crowding closer. They're still safely within a star's habitable zone. Experts say that TOI 715b might have once had an atmosphere thicker than that of Neptune, and now the planet could be in a transition state where it's losing its atmosphere. To confirm this suspicion, scientists need to do more research, and they might finally learn whether this planet is a watery terrestrial planet.
Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but we could potentially send missions there. Don't expect any extraterrestrial neighbors, though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Bernard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is... no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Bernard star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms of course. Only the Alpha Centauri trio is closer to us. Bernard star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Bernard star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Barnard's star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like, or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Barnard's star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Barnard's star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Barnard's star is tricky because, in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super sensitive instrument called Maroon X attached to the Gemini North telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs, like Barnard's star, are the most common type of star in the universe, most are way too far for us to see planets around them easily. These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants. According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory: rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real smarty. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation.
Take that giant space knife. Yes, you. It's time to visit the sun and check what's inside. First, you're slicing through the corona, aka the sun's wild hair. It's the sun's super thin atmosphere, but don't let it trick you. It's blazing at 3.5 million degrees Fahrenheit. While cutting through it, you see plasma threads whipping around like solar spaghetti. You reach the photosphere, the sun's skin. It's only about 300 miles thick, but it's super bright and sizzling at 10,000 degrees Fahrenheit. Looks like it's covered in little fiery waffles. They're called granules, and they're each about 600 miles wide. Then comes the convective zone, where hot plasma is floating up in bubbly chunks. Next, the radiative zone. This part's like molasses made of light. It takes 170,000 years for energy to crawl through here. Finally, you start cutting into the core, and boom! Instant heat wave. It's like the sun's pressure cooker. Gravity's smashing hydrogen atoms together to make helium, and it's cooking at 27 million degrees Fahrenheit. Now, you're gonna need a smaller knife, since the next candidate, Mercury, is the smallest of the inner planets, only about 3,000 miles wide. When you cut through its thin atmosphere, you see little hydrogen and helium atoms escaping inside tiny invisible balloons popping away into space. Next, the crust. Together with mantle, it's only about 250 miles thick. As our giant knife passes through, you see hard rock flakes falling off, cracking under the pressure. Mercury has a gooey outer metal core. Slice carefully, or you'll spill some liquid metal lava. Finally, you hit the inner core. Mercury has a massive metal heart. Around 85% of the whole planet is just iron and metal. It's basically a giant metal meatball. Cut through it and watch molten iron juice oozing out like spicy hot sauce. You're now approaching Venus, the hottest planet out there. We're talking about average temps of 870 degrees Fahrenheit. Hot enough to melt lead. You slice through the atmosphere and it's crazy. Thick clouds of sulfuric acid swirling everywhere, and it's mostly carbon dioxide. Like a bad greenhouse on steroids. Pressure there is insane, like being 3,000 feet underwater on Earth. Thick yellowish clouds are puffing around the blade, sizzling like acid rain. Then comes the crust. A thin shell of mostly basalt, just 6 to 18 miles thick. It's like cutting through a crispy rock pizza crust, thin but tough. Cut deeper and you're in the molten rock mantle, about 1,800 miles thick. You can see the rocky magma wiggle and ooze. Finally, you hit the metal core, about 1,900 miles wide. That's like slicing a chunk almost the distance from Chicago to LA. There's a giant iron ball inside, all molten and heavy. Alright, time to cut through Earth. Now you might need a whole chainsaw to deal with this rocky planet. First, your chainsaw bites into the crust. It's thin, only about 1% of Earth's volume. You hear a sharp crack as the brittle rocks snap and crumble. Dust and tiny minerals puff out, and the crust breaks into chunks, like snapping a hard cookie. Next, the blade presses deeper into the mantle. Thick, tough rock that's solid but kinda squishy if you wait long enough. As you slice, the hot rock kind of oozes and bubbles, leaving a warm trail along the blade. Keep going, and you hit the outer core, a huge sea of molten metal. Suddenly, the knife slides through thick, glowing liquid iron and nickel, like cutting through a giant cosmic lava lamp. Finally, you smash into the inner core. Solid metal this time, like a glowing steel marble buried deep inside. The blade scrapes across its dense iron-nickel surface with a harsh grind. It's blindingly bright and insanely hot here, hotter than the surface of the sun, and the pressure would squash any real blade flat. Put the chainsaw aside. For the next planet, you'll need something of a more modest size. You're zooming over to Mars, the last of the rocky inner planets. The knife breaks through Mars's crust. It's thin and solid, made of volcanic basalt rock. As the blade cuts in, fine reddish dust, like cosmic talcum powder, puffs up, drifting everywhere. The crust doesn't crack into big plates like Earth's. It's one big solid shell. Next up, the mantle. Think of it like thick, soft, rocky toothpaste. Not totally solid, but not mushy either. The knife slides through it with some resistance, and you see glowing silicate goo in red and orange shades, swirling around the blade. The mantle is thinner than Earth's, only about 800 to 1,100 miles thick, so you don't have to wait long to get to the juicy middle. Finally, you hit the core, a metal mix of iron, nickel, and sulfur. Mars's core is molten, but it's cooler and more chill than Earth's. In any case, it's easy to cut through, no effort needed. We're coming close to Jupiter, the biggest dude in the solar system. Jupiter is a gas giant, basically a giant balloon filled with crazy stuff. As you cut it, you don't hit solid ground at first. Instead, it's all thick, swirling gas, mostly hydrogen, around 90%, and helium. It must feel like slicing into super thick whipped cream that never ends. As you go deeper, the gas gets so squished that it turns into a thick liquid. The blade pushes through layers of swirling storms and colorful clouds that whirl around. Keep going, and the gas becomes metallic hydrogen. The knife slices through a glowing, electrified liquid that crackles around the blade, like you're cutting through electric jelly. Finally, somewhere way deep inside, you reach the core, which might be a molten hot ball of liquid or a giant rock heavier than 14 Earths. Nobody's totally sure. But if you could slice through it, the core would be hotter than 43,000 degrees Fahrenheit. A regular blade would melt instantly or be crushed from all that pressure. It would be pretty tricky to cut open the next planet, not because it's too hard or rocky, but because there's basically nothing to cut through. In Saturn's outer layer, your knife hits thick, swirling gases, mostly hydrogen and helium, but with some funky extras like methane, ammonia, and water vapor. As you cut, a smoggy orange haze puffs out. That's all the sulfur giving Saturn its groovy look. The atmosphere and surface blend together. No hard ground here. As the blade digs deeper, the gas gets squeezed tighter and tighter. hydrogen starts turning into thick liquid, and your knife leaves trails through this gooey, glowing layer. Keep going down, and suddenly, the liquid gas turns into metallic hydrogen, shiny and electric, crackling around your blade like a sci-fi lightsaber. Deep inside, you might hit a rocky core, but no guarantees. It might even be liquid rock, glowing and swirling beneath all that gas. Next, we're gonna split open an ice giant, Uranus. Its atmosphere has enough methane to give the planet that cool blue-green glow. As your blade moves, a faint icy mist sprays off. It's like slicing through a cold, foggy cloud. Next, you slice into the ice mantle, which makes up about 80% of the planet. But don't think frozen popsicles. This is a thick, hot, gooey soup of water, ammonia, and methane ice. The blade pushes through this dense, slushy ocean with little bubbles and steam escaping as you go. Then, bam! Blade hits the rocky core, small and dense, half as heavy as Earth. It's cooler than most cores, about 9,000 degrees Fahrenheit, which is still crazy hot. The blade scrapes over solid rock with sparks flying off like cutting metal in a cold workshop. Neptune's also crazy cold, but cutting it feels different. When cut, it whips clouds of frozen methane flying past at 1,200 miles per hour. It feels like slicing through a freezing, super windy blizzard. Next, you plunge into the mantle, a thick, boiling hot soup of liquid water, methane, and ammonia. The knife pushes through this dense stew with bubbles popping and steam hissing. Temperatures here range from 3,000 to 8,500 degrees Fahrenheit. Even deeper, the blade hits Neptune's solid core, mostly iron, metals, and silicates. The blade scrapes along this tough metal center, sparks flying like you're welding the heart of the planet. Now, comment below, which planet was the most satisfying to cut through?
Some time ago, the James Webb Space Telescope spotted a super bizarre space object flying through our galaxy. First of all, it's not orbiting any star. It's a rogue object, just drifting through space on its own. Even better, this wandering thing apparently has a cake-like atmosphere, and examining it can be crucial in our future exoplanet research. Plus, it can help us understand how gas giants evolve over time and what might happen to Jupiter in the future. You may object that Earth has a layered atmosphere too, with 5 major and several secondary layers. But on Earth, the air is mostly nitrogen and oxygen. As for other planets, they're different. Take Venus, for example, where the atmosphere is super thick and filled with sulfuric acid. There are exoplanets with water vapor clouds, or ones where the clouds are literally made of hot sand. But what about our rogue object? By the way, I have no clue why it got this reputation, but for some reason, scientists chose to call it SIMP. Ouch. Anyway, it seems to have its own unique combo, with cloud patches and weird chemical reactions happening high up. It is covered in clouds made of iron and magnesium, and its atmosphere has carbon-based chemicals floating around. Scientists have spotted auroras on it. Yep, like the northern lights we have on Earth, but way out in deep space. It's the very first time researchers have been able to do a sort of weather report on a rogue object like this. The next weirdness? The object doesn't really fit into any box. It's not a regular planet, because it doesn't orbit a star. But it's also smaller than a brown dwarf, which is something like a failed star. So it's something in between. Not quite a planet, not quite a star. And while it's not dangerous in the we're all doomed kind of way, scientists say rogue objects like this could actually mess things up pretty seriously if they wandered too close to a solar system. Their gravity might throw off the orbits of planets, which could lead to instability, or even space collisions. So yeah, while our rogue friend is not a threat right now, it might become one in the future. Now, this rogue object has some crazy stuff going on. First off, its day is only 2.4 hours long. Like, imagine the sun rising and setting in that time. That's real fast. It's also hanging out about 20 light-years away in the Carina Nebula, which isn't super far in space terms. Another thing that makes this guy special is the fact that it's the brightest free-floating object of its kind that we can see from the northern hemisphere. And since it's just drifting in space without a nearby star messing with our view, it's been directly photographed by telescopes, like NASA's Spitzer. That's actually super rare for stuff this faint and far. When scientists checked it out in infrared, aka heat vision, they noticed that the atmosphere of this rogue object was acting weird, like it kept changing, sometimes more heat, sometimes less. Something funky was going on, but what exactly? So, in July 2023, one team of scientists used the James Webb Space Telescope to dig deeper. They pointed it at SIMP and gathered a ton of data, around 6,000 measurements in just a few hours. First, they looked at shortwave radiation, which is kind of like high-energy heat, and then they did the same with longer waves a few hours later. They discovered that the brightness changed differently depending on the wavelength. Some parts of the atmosphere got brighter, some dimmer, and some didn't change at all. It was all over the place, but they noticed a pattern. All the changes fell into 3 groups. Each group had its own vibe, like its own little signature of what was going on in the atmosphere. And it turned out that the mysterious object wasn't just floating alone in space. It was super dynamic, with layers of clouds and gases doing their own thing. It could mean 3 different things were going on in the atmosphere. To figure out what exactly was behind all this, they built models of the rogue object's atmosphere. Apparently, the first group of curves likely came from low clouds made of iron. Yeah, iron, like actual metal clouds. The second group seemed to come from higher clouds made of this mineral called forsterite, which is basically a magnesium-rich crystal. And it looks like these cloud layers aren't smooth, they're patchy. That patchiness could explain why the light coming from them keeps changing so much. As for the third group of light patterns, they weren't coming from clouds at all. The light seemed to be coming from way above the clouds, from what they think are hotspots in the atmosphere. These hotspots are probably connected to radio auroras, kind of like Earth's northern lights, but happening in the radio part of the light spectrum instead of visible light. But even after all that modeling, there were still some mysteries left. Like, the first group of curves was all over the place, more than they expected. So they think it might be because of carbon-based gases like carbon monoxide floating around. They might absorb certain types of light at random times. In any case, this is the first time we've actually seen this kind of atmospheric chaos directly. But the few hours the researchers spent watching it weren't enough to fully figure it out. To really get the full picture, they'll need days of data, and they're hoping to use NASA's Nancy Grace Roman Space Telescope, set to launch in 2027, to dive even deeper. Even though this mysterious object is not a rogue planet, they're definitely worth mentioning. These are basically planets that got kicked out of their home solar system. Yeah, like straight up evicted. When a planet forms, it's usually hanging out with a bunch of other planets around a star. But early on, things can get super chaotic. You know, planets crashing, shifting, getting too close to each other. And sometimes, one gets yeeted right out of the system. So, since they're not tied to a star, these rogue planets are just cruising through the galaxy, totally solo. If they happen to float near something massive, like a star or a black hole, that thing's gravity can tug at them. But otherwise, they just keep drifting. Most of them probably got booted when their system was still forming, and everything was a mess. But according to a NASA scientist, even mature systems can throw a planet out if the orbit gets too weird or something big knocks into them. Now, the next planet we gotta discuss isn't rogue. It has a parent star and all. But there's another cool thing about it. It's still a baby in the middle of forming, and it's pretty rare to catch in action. The baby is already about 3 times the size of Jupiter, the largest planet in the solar system. It's part of a system about 400 light-years away. It's been growing for about 5 million years, munching on gas and dust from the disk around its star, kinda like a cosmic buffet. But the thing is, when astronomers checked out the chemicals in the planet's atmosphere using a big telescope in Hawaii, things didn't add up. They were specifically looking at carbon monoxide and water, which can help figure out how much carbon and oxygen is floating around in that atmosphere. Turns out, the planet's chemical mix doesn't quite match the stuff in the disk it's forming from. That's a big deal because it goes against what scientists thought they knew about how planets are supposed to form. Basically, it's saying, hey, your fancy models might be a bit too simple. Planets are supposed to form by clumps of gas and dust crashing into each other and sticking together. Over time, they build up into full-blown planets. If that's true, then planets and their surrounding gas should have the same kind of stuff in them, chemically speaking. But PDS-70b is doing its own thing. So the scientists came up with two ideas to explain what was going on. It might be forming from solid stuff, like dust and ice, not just the gas in the disk. That solid material has carbon and oxygen trapped inside. So, by the time it melts and goes into the planet, it's already changed the chemistry. Or the gas in the disk got more carbon after the planet already formed. Luckily, there's another planet in the same system, PDS-70c. And scientists are hoping that by checking it out too, they'll be able to figure out the truth. This planet is as light as that piece of fluff stuck to your sweater. In the scientific world, it's called WASP 193b, but let's call it the Cotton Candy Planet. It's located around 1,200 light-years away from us. Sure thing we'll never see it with our own eyes, but scientists say the Cotton Candy Planet is pretty much Jupiter's bigger, bouncier cousin, 50% more massive. It has an extremely low density combined with other factors, such as high temperatures and the infrared brightness of its host star, that make it look special. May I have a close-up here, please? Thank you. See how fluffy it is? Right now, you understand that it would be impossible to stand on its surface. Anyways, it's not often that you meet something like WASP 193b at a planetary party. Such planets might be fluffy because they're getting cooked by their parent stars, puffing up like a marshmallow that's seen too much campfire action. But the thing is, if you're that close to your star and mostly made of a hydrogen-helium cocktail, you're not gonna keep your puffiness for long. It's like trying to hold on to a balloon during a hurricane. Exoplanets like this fluffy guy here are pretty rare, but there's also WASP 100-07b, and it looks squishy too. This one kicks back 200 light-years from us, and it chose the constellation of Virgo as its official residence. From some perspective, you might say that this planet is a copycat of Earth. It has helium, and its atmosphere contains sulfur dioxide. There's some resemblance for sure, but WASP 100-07b has the density of a marshmallow. It means we can snoop through its atmosphere easier than we could with a heavyweight like Jupiter. Scientists were beyond surprised when they peered through their super space goggles, the James Webb Space Telescope's MIRI-cam. They spotted clouds made of the stuff that builds beaches, silicate, or as you might know it, sand. Imagine sandcastles in the sky. Those sound clouds are way up there in the penthouse suite of WASP 100-07b's atmosphere, where the thermostat reads a breezy 932 degrees Fahrenheit. Normally, you'd need 1,832 degrees Fahrenheit to cook up this kind of cloud, so scientists are scratching their heads. How did those grainy puffs get all the way up there? Turns out, WASP 100-07b might be running its own sandy water cycle, but with scorching silicates instead of H2O. Silicate particles get whooshed up from the sizzling lower levels by some sort of cosmic elevator, and then they cool off, party together as clouds, and sprinkle down a silicate drizzle. Nobody's packing sunscreen for this kind of sandstorm, though. Now look at this Kepler planet family located in the Kepler 51 star system. This cosmic three-pack hangs around 2,400 light-years away, looking huge but having the same density as your favorite snack. and it's cotton candy yet again. Scientists have been digging into what these space treats are made of. They now believe these puffball planets are big hydrogen-helium gas balloons with a generous smearing of methane haze. It also turns out these planets might be going through a cosmic downsize. Now, let's talk about a planet called Mascara 5b. Nope, it doesn't look like one of those cosmetic tubes from your mom's drawer. Scientists say it's one of the hottest planets ever discovered. They call it an ultra-hot Jupiter, showing off its impressive size, almost twice as big as our very own Jupiter. The dayside temperature is around a scorching 4,892 degrees Fahrenheit, while the night side hits 4,172 degrees Fahrenheit. No chance for any sort of life to survive out there. Actually, it's the second hottest nightside temperature ever recorded. To put it in perspective, the temperature of molten lava sits between 1,292 degrees Fahrenheit and 2,282 degrees Fahrenheit. So, the planet is a whole lot hotter than this scorching liquid rock. Its temperatures even surpass the melting point of most metals, which is around 3,632 degrees Fahrenheit. Scientists mention that the insane heat on this planet is comparable to the exhaust of a rocket engine. Back in 2005, one famous star called... Wait, is that a name or a phone number? Whatever. So, turns out this star has a hot sister, and they have very similar names. This hot sister has B at the end. Well, this place looks like something from a sci-fi movie as it rocks a mesmerizing blue marble vibe, according to NASA. Such an appearance results from an atmosphere packed with hazy clouds laced with glass. The rain on this planet is glass-filled precipitation that likes to fall sideways, thanks to fierce winds blowing at a speed of 5,400 miles per hour. And yeah, it's the hot sister for a reason. Scientists have measured the daytime temperatures in this nightmarish world. It's around 1,700 degrees Fahrenheit. So when it rains on this planet, it's more like molten glass pouring down instead of your typical waterworks. You may not know it, but space is swarming with wasps. I'm talking about planets called WASP. Meet WASP 76b. This sizzling hot Jupiter-like planet is so out of this world, it rains iron at night there. The daytime side is no less of a fiery nightmare. The temperature there is about 4,300 degrees Fahrenheit. WASP 76b may be slightly smaller than Jupiter, but don't underestimate its grandeur. This fireball is located 640 light-years away from Earth, and its terrifying climate is the result of one seriously extreme orbit. You see, these gas giants are fittingly known as hot Jupiters. They like to keep it hot, so they orbit way too close to their scorching host stars. In this case, WASP 76b is nearly 10 times closer to its star than Mercury is to our Sun. That's way too close for comfort, leaving this rebellious planet tidally locked to the star. So, while one side basks in eternal light, the other is trapped in perpetual darkness. 55 Cancri E is a total gem. It's the raddest super-Earth ever spotted. Scientists initially believed it was packed with so much carbon that its insides were blinged out with diamonds, thanks to insane pressure and sizzling temperatures of 4,892 degrees Fahrenheit. But researchers put a dent in the diamond hype, showing there was actually less carbon than we had originally thought. Well, diamonds aren't actually that rare and expensive after all. They're just well marketed. The last destination for today is GJ 1214b, located 40 light-years away from Earth. This planet is like a supersized Earth, almost 3 times bigger in diameter and a whopping 7 times heavier. It orbits around its red dwarf star faster than you can finish a pizza, finishing a complete loop every 38 hours. But it's not just the planet's size or orbit that's out of this world. It's pretty hot out there, with mind-melting 450 degrees Fahrenheit. But the coolest thing is that this planet is practically drowning in water. The sizzling temperatures and crazy high pressures on GJ 1214b create some super cool materials like hot ice and superfluid water. Superfluidity is something that happens in liquid helium when it's almost as cold as it can get. On Earth, water totally missed the memo on being superfluid because it needs ridiculously low temperatures and off-the-chart pressures to pull off that trick. Still, there's not much use in superfluid water. Even if you try it, you'll just get dehydrated.